Assalamu alaikum students. This video is on exercise 1.3 question number 8. In question number 8, question states if A is equal to 1 2 0 1, B is equal to 1 1 2 0, then verify. For first part we have A plus B whole transpose is equal to A transpose plus B transpose. Left hand side states A plus B whole transpose, putting the value of A which is 1 2 0 1 plus value of B 1 1 2 0. Adding the corresponding entries we get 1 plus 1 2, 2 plus 1 3, 0 plus 2 2, 1 plus 0 1. Now taking the transpose by interchanging the rows into columns we get 2 2 3 1. Moving on to right hand side we have A transpose plus B transpose. Putting the value of A we get 1 2 0 1 plus 1 1 2 0. Taking the transpose by interchanging the rows into columns 1 0 2 1 plus 1 2 1 0. Now adding the corresponding entries we get 1 plus 1 2, 0 plus 2 2, 2 plus 1 3, 1 plus 0 1. As we can see that both the entries in the left hand side are equal to right hand side, so hence we can say that A plus B whole transpose is equal to A transpose plus B transpose. Now second part is A minus B whole transpose is equal to A transpose negative B transpose. For left hand side we have A minus B whole transpose, putting the value of A 1 2 0 1 minus 1 1 2 0. First subtracting the entries we get 1 minus 1 0, 2 minus 1 1, 0 minus 2 minus 2, 1 minus 0 1. Now taking the transpose we get 0 minus 2 1 1. Moving on to right hand side which states A transpose negative B transpose. Putting the value of A we get 1 2 0 1 transpose minus value of B is 1 1 2 0 transpose. First taking transpose by interchanging rows into columns we get 1 0 2 1 minus 1 2 1 0. Now subtracting the values we get 0 minus 2 1 1. By comparing these values to the left hand side we can say that all the entries are same, hence we can say that left hand side is equal to right hand side. Third part states A plus A transpose is symmetric. For this first we have to find A plus A transpose. A plus A transpose is equal to 1 2 0 1 plus 1 2 0 1 transpose. First taking the transpose we get 1 0 2 1. Now adding the corresponding entries 1 plus 1 2, 2 plus 0 2, 0 plus 2 2, 1 plus 1 2. Now taking the transpose of this matrix A plus A transpose whole transpose is equal to 2 2 2 2 transpose, which is equal to 2 2 2 2, which is also equal to our starting matrix which is A plus A transpose. As we can see that A plus A transpose is equal to A plus A transpose, so we can say that A plus A transpose is symmetric. Moving on to matrix part number 4 which is A minus A transpose is skew symmetric. First finding the value of A minus A transpose which is A minus A transpose, putting the value of A we get 1 2 0 1 minus 1 2 0 1 transpose. First finding the transpose which is 1 0 2 1. Now subtracting the values we get 1 minus 1 0, 2 minus 1 2 minus 0 2, 0 minus 2 minus 2, 1 minus 1 0. Now taking the transpose of this matrix A minus A transpose whole transpose is equal to 0 2 minus 2 0 transpose, which is equal to 0 minus 2 2 0. Taking minus common from all entries we get minus 0 2 minus 2 0. So from here on we can say A minus A transpose whole transpose is equal to minus 0 2 minus 2 0, which is also the value of A minus A transpose. Hence it is stated that A minus A transpose whole transpose is equal to negative of A minus A transpose. That's why we can say that this matrix is skew symmetric. Moving on to part number 5 which is B plus B transpose is symmetric. Finding the value of B plus B transpose by putting the value of B which is 1 1 2 0 plus 1 1 2 0 transpose. Taking the transpose, which is 1 2 1 0. Now adding the corresponding entries, we get 2 3 3 0. Taking the transpose of this matrix, we get 2 3 3 0 transpose, which is equal to 2 3 3 0, which is also equal to B plus B transpose value. So we can say it is also a symmetric matrix. Moving on to part number 6, which is B minus B transpose is skew symmetric. For this, first find the value of B minus B transpose by putting the value of B, which is 1 1 2 0 minus 1 1 2 0 transpose. Taking a transpose, we get 1 1 2 0 minus 1 2 1 0. Subtracting the values, we get 0 minus 1 1 0. Now taking negative sign, first taking the transpose, we get B minus B transpose is equal to 0 minus 1 1 0 transpose, which is equal to 0 1 minus 1 0. Now taking negative sign common, we get negative 0 minus 1 1 0, which is also the value of B minus B transpose. So we can see that B minus B transpose is equal to negative of B minus B transpose. So we can say that it is also a skew symmetric matrix.